Hello everyone, in this video I want to talk about introduction to inequalities and also interval notation as well as set builder notation. So I right after this video, uh, maybe there will be some practice question for this unit and then we're going to move on to the next unit. So what are inequalities? So inequalities is the comparison between two expressions that is not strictly equal. So if we have like b where x is greater than b, this means x is greater than b. This means x is less than b. And also, what if the b is inclusive or equals? So x is greater or equals to b and x is less or equals to b. That means x can be greater or equals to b, or x can be less or equals to b. So for example, for x is greater than b, that means the values of x, let's say x is greater than 2. That means x must be 3, 4, and so on, right? What if x is less than 2? That means x must be 1, 0, -1, and so on. This is where it's in the integers, okay? It has to be in the integers. Okay, what if x is greater or equals to 2? So we include 2. So 2, 3, 4, and so on. Okay, and what if x is less than or equals to 2? That means, of course, 2, 1, 0, -1, and so on. Okay, that's for greater, less than, greater or equals, or less or equals, less than equals. So inequalities can be like this in this form: a is less than x and is less than b. Okay, so it's comparing two values to x, where a is less than x and x is less than b. So that means in this case that means a must be less than b. Okay, so what does this mean? This is called um, exclusive inequality. That means the boundaries is called boundaries is not equal. So not equals to the x. That means we're not gonna write a in the so-called set, which is a group of numbers like this. So this is exclusive inequality. How about there's another term called inclusive inequality. Well, it has the equals, so it can be a and there is a and there is b in the group of numbers. Okay, so an example, oh yeah, it can be also greater. A is greater than x, that means it's greater than b, and it can be also a is greater or equals to x and it's greater or equals to b. For example, if we have 2 is less than x is less than let's say 4, that means our possible numbers will be what? 3, right? How about 2 is less than or equals to x is less than or equals to um, say 4 again. That means we include our 2, 3, and 4. We don't write it as like this, but we put a curly bracket. This is called a set. For set theory, it will be on a separate video, so it will not be on pre-calculus. Make sure to watch that, but I haven't uploaded. Maybe I will upload that series soon, but I don't know. So 3 and 2 is less or equals to x, and this less than equals to 4. That means it includes 2 and 4. So 2, 3, and 4. So if 3 is greater equals to x is greater equals to, say, -1, so it must be between -1, 0, 1, 2, 3, and that's it. And also, an inequality can be partially inclusive and exclusive. So 2 is less than equals to x, and it's less than, let's say, 5. What does that mean? So we still have 2 because there's an equal sign. So we have 3 and 4 because there's not an equal sign into 5. So we exclude 5. Okay. Again, the same example, but we include 5. It means we exclude 2. We start from 3, 4, and we add 5 here. Okay. Now there's something called interval notation. So the interval notation for this interval notation will be open brackets for exclusive inequalities. So A, B. Okay. It works for both of these as long they both are exclusive. Inclusive, you put a close bracket. This is called an open interval, or this is called a closed interval. That means the interval includes A and B. So it includes A and B. And what if in this case, well, it's when it's partially inclusive and partially exclusive. So if in a case like A is less than equals to X and is less than B, that means we put um, the square bracket in A, and then comma, since B is exclusive, so we put the bracket, the non-curly bracket. Okay. And what if it was A less than X and less than equals to B? The same. The closed bracket, the open bracket, or the, what do you call it, the parentheses, and put B, we close the bracket. So it includes B, but excludes A. And what if we had infinity? Well, infinity, we cannot like get to the infinity. That's why if we have an inequality from negative infinity and then infinity, which axis between negative infinity and positive infinity, that means we have to have a parentheses, not a closed bracket. And what if it was some constant k, number A here? The same thing, since this is there's no equal sign, that means we are, the interval notation would be all open brackets. How about negative infinity is less than x is less than or equals to a. That means since a is included, so we have a closed bracket here. So the inequality here, we can write if there was an infinity in the inequality, we cannot write equals because we cannot actually be at the infinity but approach it. So we write it as not equal but strictly less than. Okay. So another example, another thing that if we have negative infinity is less than x is less than, let's say, 1, and we have another inequality which states that y 1 is greater than or equals to x is greater than, let's say, no, 1 is less than equals to x and is less than infinity. That means this still would be negative infinity to positive infinity, the interval range, the interval notation. Because if we see that negative infinity and positive infinity would include the 1, right? I mean, the interval notation for this would be brackets, close brackets, 1 and infinity, right? While this one, um, the left side would be negative infinity and 1 with an open bracket. Well, to write this, we write a union. This is called union, where they are joined together. So negative infinity and positive 1, union 1 and positive infinity. But since we're going to negative infinity to positive infinity, and that includes 1, so we don't need to write 1 here. So we just write negative infinity to positive infinity. Okay, we're gonna get into that more in the later videos. Okay, so after interval notation, we get into the set builder notation. So set builder notation is like this. We put a curly bracket x such that, this is called such that, this label, it can be this or it can be this. Okay, such that, according to the person how to write the notation. So x such that the rules or the conditions of x. So this is x, so x such that condition of x. Let's say it was in between some number. So if a is between x is, and x is and less than b, that means the set builder notation will be x such that a is less than x is less than b. Okay, so for some number which is uh, greater than a but less than b. And another example would be, so oh yeah, since this is just a regular x, what if we put x such that x is in, this is called element. What does an element mean? So if we have let's say a set or a group of numbers 1 2 3, and we have 3 here, then this 3 must be element to this group, 1, 2, 3, because 3 is of course in this group, as an example. But instead of writing the numbers, we write it as a and b, or as x and y. So x is in, let's say, our integers, such that a is uh, less than x is less than b. Okay, what differs from this to this? If we were to set this as to x such that it's between 2 and it's between 4, well, the numbers would be greater than 2, but it could be like 2.1, right? 2.1. It could be like 2.2, which is less than 4. Let's say 3.87. Well, there's no like, it's all of the like rationals and irrationals in between 2 and 4. If we put a condition that x is in the integer set, that means if we put x is in z, which is the integers, um, remember that I explained about uh, the number system in the first video, the first episode. In between 2x and 4, what does that mean? So we must pick the integer. What integer is between 2 and 4? Which is 3, right? So the possible values of x here must be 3 in this set Boolean notation. So a set builder notation is x such that, yeah, the condition of x. So the set builder notation will be used a lot, especially in the analysis case. Okay, so I believe that's it for this video. So in this video, you've learned about um, the introduction for inequalities and also interval notation as well as set builder notation. So again, for the main points of set builder notation is that you put our variable x and such that conditions of x. It can be less than, greater or equals, as long it's the condition of x. Okay, so that's it for this video. Thank you and see you on the next video.